Let's look at the SQL that we will need to know in order to go from our data dictionary to the actual database. So we went from our ER diagram to a set of relations, and from the relations, I asked you to create a data dictionary. When you're creating the data dictionary, you're starting to think in more concrete details. What's the data type? Is the primary key going to be surrogate? What are the alternate keys? What's the minimum cardinality? That's going to determine whether the foreign key is required or not required. And you may have other constraints. Constraints are based on business rules. In many databases, you will use the command called create database to start. In Access, you have the GUI to create a blank database. But in, let's say, SQL Server, I'm going to show you an example. You will use the create database command. Here is Microsoft SQL Server Management Studio. It is an interface to SQL Server. I have just a test SQL Server on my computer, and I've created a new query. And here's the command to create a database. The command go means do it. It's kind of like our db.execute. And it said it's completed. If I refresh my object list, you will see there is my DB. There's no tables in there yet. I would need to be adding some create tables in here, but the database has been created. In Access, you will simply need to use the GUI to create it. File new, click blank database, decide where you're going to save it, and create. I know when we did the select statements, we were using the query window in the SQL view, but the DDL does not work in the query window, so we'll need to do it with the VBA. When you're creating a table, what you need to know first is the data dictionary, developed from the ER diagram and your business rules. And you need to know the data type for the DBMS you will be working with. Unfortunately, this varies a lot depending on your DBMS. That ANSI standard is not dependable. You might get a lot of errors if you just go by the ANSI standard. So know data types for your database. Here is the syntax for the create table DDL command. You will start with the keywords create table, assign a table name. A table name must be unique within a database. And then you'll have a pair of parentheses, opening and closing, and inside that are the columns you're defining in the table. Within that set of parentheses, you will give the field name here as the first item and a minimum of the field name and the data type. Spaces separate the field name from the data type, at least one space, but it is, for readability, good practice to align that. So make enough spaces so that these align. Then you will have one or more constraints. The constraints down here would be not null, a check constraint, a default constraint. And if you have multiple constraints to assign to column 1, for example, you just will separate each constraint with a space. After you've listed all your constraints, you will do a comma and then indicate the next field. It is also standard to put each field on its own line for readability. After you've completed all the columns, which is happening right here, you can list some constraints at the bottom of the create table command before you close it. So primary key can also be added as a constraint here instead of placing it up here on the line where you're defining the field. When you use the primary key constraint, notice that you're going to put the fields that comprise the primary key inside a pair of parentheses, and if there's more than one field, it'll be a comma separated list. After you've defined all of your constraints, you're going to put a comma after each one. Notice the foreign key constraint. After you've got your parentheses that define the foreign key, you will use the keyword references, and then this is the table that holds the primary key side. Then finally, before your closing parentheses, you want to make sure you do not have a comma right before the closing parentheses or you will get an error. So after you've defined all of these values, the last line, no comma, and then just close it. I like to make sure that I have a semicolon in that too. Other DDL commands are the select statement, that we've been calling them DML, but you can use a select statement to make a table. You can create a table with a select statement as a subquery, similar to where you used a select statement in the from clause that we discussed last week. It automatically creates the table and copies all of the row that the select statement generated. Other DDL could be creating an index or dropping an index or dropping a table. So we'll take a look at those also. Once again, those constraints are not null or unique, primary key, foreign key, check, and default. The author is using the Oracle database, and unfortunately, some of these don't work in Access. But I want you to know this for quizzes, etc. So here is ANSI SQL for check constraints. Now you're going to use check constraints for your data integrity. It makes sure that the input is valid. Suppose, for example, I have a cab table for a taxi company. Okay, and the condition of the cab needs to be one of these set of strings. Then my check constraint would be the word check and then the condition field. And in the condition field, I have a comma separated list. And since they're string values, there's quotes inside of them. Now be aware, you will not be doing this in Access. This will not work. Here is a check constraint to make sure that the data input for amount is greater than 0. Another check constraint uses the between keyword. So perhaps the cab has a year field and the year field has to be between 2020 and 2023. Here is the SQL to create this cab with cab num as primary key. And there is my check constraint right here within the declaration of the year field. And here is my second check constraint. Evidently, cab status has to have either A, B, or C. I didn't do a check constraint for condition. In this example, we're creating a table called shift driven. Notice that shift driven has 3 fields as the composite key and 2 fields for foreign keys. So the foreign key constraint here, we have the constraint foreign key references the name of the table it's referencing. So cab num is referencing the cab table. Driver num is referencing the driver table. Down here, after we've declared all the variables, we now add the primary key constraint. And it does need to go here because it's a composite primary key. The syntax of these constraints allow you to assign some names to the constraints. I did not do that here, so we'll have some in future examples. Also notice that with the decimal ANSI standard, you're going to indicate how many total digits there are in the decimal, and the second one is how many will be to the right of the decimal place. From the textbook, MS Access does not accept the default or the check constraints. So here I've got from the Microsoft website the syntax to do a constraint for a single field. Notice you can do the primary key, the unique, the not null or null, and the references foreign key constraints. These values here are related to foreign key. I'll discuss that shortly. Let's talk about foreign keys. After you indicate that a certain field references the primary key table, you have some options on what's going to happen if you delete that related record in the primary key table. So let's give an example. Suppose I have an employee and the employee got fired. You want to delete that employee record. And that employee record is related to a dependent table. So you have several options of what you want to do to delete that employee record. And this takes a little bit of knowledge about how the business operates to decide what you want to do. If you add on delete restrict, it's going to say, wait a minute. There are some related records here in the foreign key table, so I'm not going to allow you to delete it. You're not allowed to delete that record. What this will maybe allow you to do is have someone go in to check what those related records are, clear that stuff up, then you can go back and delete the record in the primary key table, or maybe you'll just keep it. Or another option is on cascade delete. And in this case, you might want to do that. Okay, I'm deleting the employee. Go over and find all related records and dependent, delete those two. We're cascading that delete. And finally, on delete set null. So I'm deleting that employee. Go over to the dependent table. There's no longer a primary key with that employee's ID in it. So you're going to just set the employee ID and the foreign key to null in the dependent table. Here I have in Access created the artist table and executed it. And I've created the work table from the example earlier. And because there was not an optionality, I wrote not null here. I wrote long for the data type because it's relating to an auto increment. Here's the constraint. I've assigned a name. This is just a name I made up. FK for foreign key. References the artist table. Let's talk about indexes. Indexes are used to speed up the joining of tables or the searching through tables or sorting. Your user wants speed, and one of the best ways you can provide this to the user is by creating indexes. You will create an index for your foreign keys because that's how you're doing the joins. You're probably not going to make that unique unless the relationship is one-to-one. You're going to index your secondary keys. These are fields you have identified that you search on a lot and probably are not unique. If they were unique, you probably would have made them an alternate key. And you're going to index the alternate keys. This is how you're going to make sure that those values are unique because one of the keywords in indexing is the keyword unique. So an alternate key, remember, is a field that could have been the primary key, but you decided to go with a different one. You do not have to index on primary keys. That is automatic, as it should be. Some rules to consider is don't get index happy because every index requires overhead on the server. Another thing to think about is data volatility. Every time you modify a field that's in an index, say a secondary key, a last name field, could be a secondary key because it's something we might search on. Every time it's modified, that index has to be modified, and that adds to the overhead of modifying and saving the record. So this is just a little indication that maybe salesperson name is searched on. That's a secondary key. Let's index it. Primary keys, they're all automatically indexed. Oh, here's a foreign key, product name. So we're going to index that one. Here's a foreign key. Going to index that one. And this is a composite entity. So we're going to index this as a group. So here is the ANSI syntax for creating an index. Create optionally unique, if that field's going to be unique, alternate keys, recall. Create unique index, you make an index name up on the name of the table and one or more columns that you plan on indexing. Think of an index as the index in the back of a book. It helps you find things faster. With Access SQL, it's pretty much the same, but you have the option to indicate whether you want the field to be ascending or descending. Here's some examples of SQL I created for our work and artist table. I created an index because it's a foreign key. On the work table, artist ID. Now you get to make this name up, and you can use this name later when you want to drop an index, which we'll get to in a minute. But the work table, artist ID, I indexed it so it could have faster joins between artist and work. If you recall, last name, first name in artist was an alternate key. So here we have a composite index of two fields. To delete a table or an index, you're going to use the keyword drop, table or index, followed by the table name or that index name that you just made up when you were creating the index. Notice that in Access, it's a little bit different than ANSI. You're going to use drop index on the index name. Another command is alter tables. So you might want to modify tables. You might want to say, well, I need to add a new field. Maybe you want to change the data type. Maybe you realized you had an integer and a short wasn't big enough, so you're going to change it to a long. So you can add, delete fields, and you can modify fields by making them a new table, or you can alter a table and add a constraint.